Okay, guys, so we are done with this chapter of multiple integral, but there are some points that I would like to explain more for you to make it clearer. If you remember, on page 49, we had a double integral, and we used this substitution to calculate the double integral, and we solved it, if you remember. And the answer was 2/9. But one thing that I would like to mention or explain for you, okay, you may wonder, okay, when we use this substitution, the region R under this substitution is mapped to region G in UV plane. But why? Why is G like this? How to get G? This is my point. Okay. Look at here. Region R is bounded by these three lines: x plus y equals 1, y equals 0, x equals 0, right? Okay, now look at this page I have done for you. If you use this substitution, you can calculate to see that x plus y equals u, and x plus y equals u, y minus 2x equals v. Okay, you can see it here using these two equations. Now look at here, we said that the region R is bounded by these three lines, right? X plus y equals 1, x equals 0, y equals 0. So look at here now. When you say x plus y equals 1, x plus y equals u equals 1. When you say y equals 0, it means 2u over 3 plus 2u over 3 plus v over 3 equals 0. This is equivalent to saying that v equals minus 2u. When you say x equals 0, it means u over 3 minus v over 3 equals 0. From here we get v equals 2u. So look at here, this region R is bounded by these three lines: x plus y equals 1, y equals 0, x equals 0, which are equivalent, or in terms of u and v, it's equivalent to saying that u equals 1, v equals minus 2u, v equals u. Now look at this page. You try to sketch these three equations, this one, in two-dimensional space represented by UVW. It means we have three lines. 1, 2, 3. These are lines in UVW space. In two-dimensional space represented by UVW. Look at here. U equals 1, V equals U, V equals minus 2U. So this is how we obtain the region G. When we say the region R is, look at here, region R is bounded by these three lines, it is equivalent to saying that the region G, which is the image of region R under this substitution, is bounded by these three lines: U equals 1, V equals U, v equals minus 2u. And of course, if you remember, we have done this. When we set up the integral, we say u is from 0 to 1 and v is from minus 2u to u. Okay, this is the reason I try to explain you how to obtain the region G. And for your exercise, okay, look at here, the previously, we have another example on page 46 that on page 46, if you remember, we use these two substitution here. We use x equals u plus v and v equals 2v to calculate this integral. And if you remember, we calculate this integral and we got the answer here too. But of course, you may wonder why under this substitution, how to get the region G here, how to get the region G from region R. Just like the previous example I explained to you, I leave it to you to figure out as an exercise, okay? To figure out how to get the region G from R. I just give you some indication. Look at here, y is from 0 to 4, and here y equals 2x. This means okay, if I take y to the right hand side, 2x minus y equals 0, and this is equivalent to saying that if you take this y to the right hand side and 2 to the left hand side, this is equivalent to saying that 2x minus y equals 2. Okay, so this line is 2x minus y equals 0. This line is 2x minus y equals 2. And look at here, we have 2x minus y. So I leave it to you as an exercise to see why the image of region R is G. Y for G, U is from 0 to 1, V is from 0 to 2. Just like previous example. So totally we are done with this chapter. And I wish you good luck in final exam. And if there is any comment or any problem or any question, you can contact us. Good luck.